Hello, this video we will show several properties of expected value. So we know expected value, also called the mean of the random variables. And if this variable is a constant, so it's not a random variable, so it's very easy. The expected value of this value is also its value self because there are no randomness. This variable has only one value, right? And if a and b both are constant and another random variable x, so the expected value of the linear combination of ax plus b is the expected value of x times a plus b, because expected value of b is itself, right? So we can use a times expected value of x plus b. So these properties can be generalized if there are more than two variables. So x1, x2, xn are also random variables, and a1, a2 until an and b are also constants. So we can, if we want to calculate the expected value of these linear combinations of several random variables with several constants, so we can take each part out and calculate the expected values of each random variable times its corresponding constant parameter, then plus b. And next property is connected with the product of two random variables. So if, say, we want to calculate the expected value of x and y, now x multiplied y, so the product of x, y. And if we know x and y are independent random variables, so independent variable means when random variable's value has no effect on the other random variable. And if this property is met, then the expected value of x times y equals the expected value of x times expected value of y. But keep in mind that this only exists from this way, not from the other way. So if we know, for example, expected value of x times expected value of y equals expected value of xy, then we cannot say these two random variables are independent. So if we only know that they are independent, then this expression exists. So, but if we know this expression exists, we cannot say necessarily that these two random variables are independent variables. And the fourth property is connected with the function of random variable and their expected value. So say gx is a function. So this function may be the linear function or not the linear function of x. So x is a random variable, and we know the distribution, the probability of x. So we know the probability of x and the distribution of x, but we want to calculate the expected value of a function of x. So this function is a gx. So we can use, if x is a discrete random variable, then we can use this way with a sigma summation, and inside the sigma is each value of x and its probability. This is fx times gx function. Then check together, then we can get expected value of gx. And if x is a continuous random variable, so we know this fx is the probability density function. So in this way, we can use the integral from the negative infinite to the positive infinite. For the expression is gx times this probability density function, and we take integral over x. So next we show one example. Let's say we know a probability density function for discrete random variable x. So x can take 3 values, and these 3 values has also their corresponding probability, and the sum of these probabilities are 1, right? Then we can calculate the expected value of x. So expected value of x is each value times its corresponding probability, then take together. So the value is minus 5 divided by 8. And expected value of x squared, we can also use the expression x squared for each value. So x minus 2 squared is 4, x1 squared is 1, x2 squared is 4, and times its corresponding probabilities. So the result is 29 divided by 8. Thanks for watching.